Good morning, students. Today we are going to learn about construction materials and concrete technology. Generally, this title of the subject is concrete technology, but we have added like construction materials just to know what are the materials that we are going to use in construction technology. So in this session we are going to learn about introduction of concrete and what is the introduction, how we are going to do it, and what is the aim of our session. So aim of the session is familiarizing the students with the basic concept of construction materials, and objectives are the session is designed to demonstrate learning outcomes, define, describe and summarization. Concrete technology, the code of this says 22CE2204 and the LTPS structure is 3020. Because this subject is having lab component, as we are going to do the practicals in this subject, and we have three lecture classes. So what is the basic ingredients or basic constituents of concrete is binding material, fine aggregate, coarse aggregate, water, admixtures. Based on the requirement we are going to see the admixtures. So the basic definition of concrete is here we are going to study about the history and basic constituents of concrete. So concrete is a construction material composed of building materials, fine aggregate, sand, coarse aggregate mixed with water, with hardens with time. So generally the setting of concrete can be done when you kept it for standby or kept it for certain time, it is going to be hardened. So concrete is the basic material for construction, where we are going to construct a huge massive buildings or bridges or tunnels. It's like a vast construction purposes we are going to use the concrete, and which gives a higher strength to the buildings. So concrete is a mixture of cement of 9 to 15%, water to 15 to 16%, fine aggregate 5 to 30%, coarse aggregate 30 to 45%, air is 2 to 6%. So this air, why we are considering air is this is nothing but a void which is formed inside the concrete, where that voids cannot be missed as of now. So up to 6% we can consider that air is there in the concrete. So beyond that 6% we should avoid air which is penetrating into the aggregate, into the concrete, so that the strength of the concrete which we have designed and which we are expecting to be will be there throughout the certain design period. So the chemical admixtures in which the cement and water has hardened by the chemical reactions, hydrations, to bind nearly non-reactive aggregate. So generally we used to use the aggregate which is good to your which enhance the strength of the concrete, not to disturb or damage the concrete validation. So the next one is 9 to 5% cement paste, that cement paste which is having 15 to 16% of water. We are going to prepare a paste, and then that mortar will be mixed with 5 to 30% of fine aggregate and 30 to 45% of coarse aggregate. Totally combinedly we are going to take a complete concrete in it. So next, what are the main constituents we are going to study is cement. Generally we used to use Portland cement as hydraulic cement, meaning they react and harden chemically with the addition of water. Cement contains limestone, clay, rock, iron ore blended with heated at 1200 to 1500 degrees centigrade, and the result product is clinkers. The clinkers is grinded and powdered to form a cement with adding of gypsum to control the setting time. So whenever we are going to prepare a concrete or prepare a mortar with a cement paste, it directly, if you don't add any of the gypsum in it, it automatically hardens quickly without giving a certain position or shape to the mortar. That's why we are using a gypsum, where we can have a setting time, where we can go for the molding procedure. So fine aggregate, normally called sand, so it's smaller than 4 mm. So there are two types of aggregate, fine and coarse aggregates. Fine aggregates are less than 4 mm, and whatever greater than 4 mm we consider it as coarse aggregate. So generally the amount of aggregates we use, fine aggregates we use in concrete is 30 to 35%. So coarse aggregate may be either gravel or crushed stones, makes up to 40 to 45% of the mixture, comprised of particles greater than 4 mm. Generally we have seen like which is greater than 4 mm we consider it as coarse aggregate. So coarse aggregate can be considered to 4 mm, greater than 4 mm, and with a percentage of 40 to 45% in the mixture of concrete. So generally if you take the concrete, and this is the basic history of the concrete, when you take the syllabus of this CT, concrete technology, the first module is basic historical background, composition of cement, concrete, and next one is constituents of concrete, cement, aggregates, tests on the aggregates, tests on the cement, concrete. Next one is material, admixtures, what we are going to add, which admixture is used in different purposes, what is the purpose of the admixture, why you are using super plasticizers, what is the functioning and the dosage of the plasticizer will be introduced or will be learnt in module 1. Second module is fresh concrete. We are going to learn about the fresh concrete, what we call it as fresh concrete, how the workability we are going to see, how it bleeds, how it is retempered, every method we are going to learn in CO2, that we call it as module 2. And in the same module 2 we are going to learn about fresh concrete and hardened concrete also. In fresh concrete means what you are preparing, what you are mixing and making into, set it for a certain time. So after setting we are going to get an output of hardened concrete. That hardened concrete can be known, the strength, the limitations, tests on the concrete, then only we can go for the construction. So CO3 is nothing but a concrete in aggressive environment. For example, when it reacts with any of the aggregate, when it reacts with any of the components other than in the concrete, we call it as concrete in aggressive environment. We are going to see the reactions, how it occurs, and what is the consequences based on the aggressive environment reactions. So we are going to learn in the CO3, we are going to learn about special concrete techniques and how we are going to pour the concrete while we are constructing a massive buildings, massive structures, different design structures and peculiar structures. So in that, how we are going to pump it, how we are going to water it, how we are going to replace the concrete from one place to another, cold and water weathering, how we are going to watering it. So special concrete techniques we are going to learn in CO3. In CO4 we are going to learn about a mixed design, or how much quantities we are going to add for different mixed designs. For example, we have different Indian standard, we have an Indian standard code to design a mixed design. So CO4 is completely we are going to design it, and we are going for testing, acceptance criteria and code provisions we are going to learn. After concrete, we are aggregates, we are going to learn about water quality, alternative building materials, concrete. So proportion of concrete mix, principles, special concretes, we have already learned. So in 302 we have learned that lab experiments are there. What are the lab experiments we are going to do? Is nothing but experiments on cement, based on the cement to determine the specific gravity of cement, to determine the initial and final setting of cement with wicket apparatus, to determine the normal consistency of cement with wicket apparatus. And these are the pictures of cement. So experiments of fine aggregate to determine the fineness modulus of fine aggregate, bulk density, specific gravity, ratio, porosity of fine aggregates. So experiments on coarse aggregates, fine aggregate, coarse aggregate, experiments on fresh concrete means workability we are going to see based on the slump cone test, workability of concrete by compaction factor apparatus. So this is called a fresh concrete, we call it as Experiments on hardened concrete means we are going to see the compressive strength of the concrete cubes, bricks, ACC blocks, or tensile strength and modulus rupture of concrete beams by using certain specimens. The specimens or the modulus molds which we are going to have a specific dimensions where we call it as a specimens. So this is all about session 1 we are going to learn, and thank you. We are going to continue with another session. Thank you.